Start recording. Okay, well, welcome to the plant spec and catalog for AutoCAD. In this webinar, I'm going to take you through a few things that we're going to talk about that I find that can present some challenges and hopefully make your lives a little bit easier. So firstly, plant design, and as you probably have realized, and what I love about this photo is that if you try and Google something about plant design, it's sometimes not as easy as it cracks up to be to try and find certain things. So a little bit about myself. Application engineer at Micrographics, part-time trying to take over the world. Yes, I know. I love all sorts of technology, etc., even rendering. So, but apart from that, for today, our agenda, what we're going to be looking at. So, we're going to do a quick look at what is actually the catalog and spec, why should we use it in PNID, and how do we then link the PNID to the 3D to make spec-driven PNIDs. Then going to go in a slightly deeper dive as to how we can create new components in the spec editor. In my personal opinion, a little bit mislabeled being a spec editor, but I'll get to that. And then how to set up the connections between components in the spec, how to set up new joint types, etc., how to create some basic specs in the catalog, ordering your components in the priorities list, and then lastly, going to go on a bit about the branch editor itself. So moving swiftly along. Now, I'm really not going to try and make this a death by PowerPoint type system. I'm going to be working a lot in the actual program, showing you the various systems as we work through it. You'll see exactly what I mean. But I do have a few slides here to show you, just as to try and give you an idea, a better idea as to how things actually come around. So first and foremost, what is a catalog and a spec? Now you'll hear us talking about this a lot. By the way, American spelling, don't accuse me of misspelling things. That's the way Autodesk spells it. So yes, catalog. Easiest way to think of it is an entire warehouse of all your parts, all the components, everything, basically everything crammed into one system. Now, it would be illogical to work with a project with maybe every single pipe size and every single bend possible and everything, because it would blow your project up massively, and it may make it difficult to find what exactly you want. And this is where the spec comes along. Now, this is the reason why there's a big difference between your catalog, which is everything in your system pertaining to a specific items. Now that's when we are looking at specs, which you can think of as a shopping list. Like your shopping list, as you can see on the right-hand side, it would be your milk, your juice, butter. So that would be our specific type of pipe. So if you're looking at Sans, it would be like the Sans 62 pipe. And then that would go with its whatever related elbow it is. I know that they've got one of the ANSI specs or something like that that works with it. But that being said, so this is how your spec then is that it's actually your list that's taken directly from your catalog, and it references back into the catalog. So we do use spec and catalog interchangeably, but generally if you're referring to creating something, and that's what I mentioned a little bit earlier, is about your catalog, because your spec editor is actually not just editing your spec, but your catalog in the background. But I'll get to that a little bit later. So what we're going to then also talk about now, and I'll show you about the actual creation of the parts a little bit later. But firstly, why do we want to use our spec-driven PNIDs actually in the PNID side? Because everybody's like, hey, wait a second, why don't you want to rather use that actually in the 3D side and keep them separate? Wait, this can be a yes and a no question, because if you've got, which a lot of people do have, is your people who are working on only the PNIDs or only working on the 3D elements, to make sure that they're both using the correct components at any one point. Like, for instance, if you've got maybe SS104 or SS416L or something like that, you don't want them to put in something that's maybe out of size, out of spec, not going to be used, etc. on that line. So it can immediately flag for them what is incorrect and point out straight off the bat that there is something wrong here. So if you take a look on the right-hand side, you can actually see my 900 line. So maybe that was supposed to be something else, and somebody accidentally routed that line as 900. you can see it's already popped up at 900 there. And that is the correct one at 100. You can see the line is the same color. And the way that you actually do this is when you turn it on, which I'll show you in a bit, it actually then flags as you're drawing, is this correct? Is this in spec? By default at the moment, it is turned off for facilitating for projects that were created before, but it is very easy to turn it back on. So how do we actually turn this on? That was pretty simple. You firstly just go into your project setup. Then underneath your PNID DWG settings, PNID specs and PNID, you just have to change it from a standard project where it is generally sitting in, and this is what it should be by default, but change it to spec driven. And that's basically it for enabling a spec driven project. You may need to, though this is unusual, actually go and map out. So you basically tell the PNID side, hey, wait a second, this is what you're talking to in the 3D elements. And so to do that, you'll see in the same place as how we were getting into our PNID DWG settings. Underneath that, there's a little part which is PipSpec object mapping. And that's pretty simple. All you have to do is go down the hierarchy, go into whatever object you're looking in. You may need to toggle between the different components from pipeline, valves, normal piping components, or specialty components. By the way, I sometimes do get asked this question, why is there a difference? In fact, they're just trying to make it a bit simpler. Your normal piping component would be anything you would have in a normal pipe run without any specialty things in it. Mainly be, and as a poor explanation there, but basically it's something like what you would encounter in any single pipe run. So you would encounter your things like your elbows, your T's, your reducers, just simple items. If you're wanting to introduce things like, for instance, strainers and that type of stuff, that is when you're going to have your more specialty pipe items. So that'll be different on every single pipe run. That being said, let me just get back to what I'm saying. So as I was saying, these would be your different subcategories. And now inside there, you've got the ability to check the mapping. So in this case, you can see I've got a butterfly valve selected, and it's showing that it's mapping to the butterfly three-way, which we will see later on when we get into the catalogs. And then the property object mapping inside there. And now all I've done is just to save a bit of space here. So this is basically what this screen over here would be what's in the property mapping over there. And in there, you can see as to what is it going to actually bring across and look up and check. And if it does fail, it will be in red as we saw previously. And in fact, if you look over there, you can actually see it's in red. So this is actually how we can then very easily make sure and check that our PNID is going to work. It's going to speak the exact same language as our 3D model should, because if you are working with the same spec that your 3D guys are using, there's no reason why you should run into any errors there. You may run into the unforeseen thing that nobody's taking into account, but that would be the exception and not the rule. Cool. So now that was basically our quick overview as to touching on the PNID side. Now, the main thing that I normally get asked a lot is actually more in the 3D side. And that is things like this. So how do we actually create a component in the spec editor? How do we set up these connections and make these things work? Because if anybody's actually done this before, you would have realized that this is not the most straightforward and simple thing. And if we jump actually into our spec editor, so this is our spec editor, and most of the people arrive here normally and they were like, oh, well, that's interesting. There's a lot of stuff here. Very interesting to see. Now, this is where it gets a little more difficult. And what I do normally say is, like, it's a good idea to start off with another pipe specking catalog so you can see what other people have done and what works. But in this case, I'm just going to show you from scratch as to what we're going to be doing. So in here, I've actually already gone and created a bit of a pipe spec, and I'm going to jump to the catalog. Or should I say the catalog itself? So in this catalog here, all the parts, and I've just made a very simple list, and it's only got 3 different sizes. It's 80, 125 to most of it. So now let's say I wanted to add in my own little part. So let's say it's something like a flange. So to create a new one, the very simplest way to do this would be to go create a new part, and this is where people can normally get to. So they'll say type of fitting. In this case, it's going to be, let's say, something like a flange. And end type is going to be maybe slip-on. Oops, I don't have anything for slip-on in this category. So let's go to flange again, and I'm just going to then maybe select. If I remember correctly, this one was SOO. Nope, not that one. Okay, just to make our lives a bit easier, I'm just going to scroll across and find one that's similar to what I'm looking for. Let's just use the lap flange one, it'll be fine. Select the sizing. In this case, I'm just going to go 80 to 100. Or let me just do 80 just to, or 100 actually, that'll make our lives nice and easy. If you did have a range, you could do a range. Now, what this will do is it will try and auto-populate a lot of it with default data. But when I go create, you'll notice that it does pull through some default data, but it's not a lot. So in here, I can put in basically, this is, by the way, a key thing, is you want to make sure that your pipe ODs match. Your pipe ODs, if they don't match, can cause you issues later on. And I'll show you what I mean there when we get into a joint. That's 104.3. Yes, I use plant way too much that I know that offhand. Length is 18, if I remember correctly. Diameter on the outside would be, D2 is 100, that is 220, if I remember correctly. In this case, I'm just going to put flange as my long description. Flange 100. Now, here's a quick trick that people always forget, is that a flange and most other objects have got not one port, but 2 ports. And this is where a lot of people fail in this, is that they will go and they'll prescribe for one port, but not the other port. And a thing like a flange or something like this, sometimes it's okay. What we can do is we can just say, set all ports to the same. It's going to give you a query. Are you sure you want to do this? You can say yes in this case. Sometimes you don't, sometimes you do. This is very situational, and I'll show you now a small exception what we do, especially for things like flanges, which we have to be careful with. Once I'm happy over here, just going to jump to my general properties. And now in your general properties, you have to be very careful of 2 or 3 things here. Firstly, you have to give it a proper name because you and the computer has to know as to what you're busy calling out. So in this case, I'm just going to say it's going to be my SO flange TMP. You can give it a compatible standard, but most of these other ones, they won't give you as much of an issue. You do want to give it maybe a short description. I'm just going to copy my description over there. But most of these, if you're going to do something over here, just make sure that whatever you're going to be mating it to, which I'll discuss a little bit later, is going to be the same. Because if things don't match, it is going to give you issues down the line, which I'll show you now. Weight unit, kg, and these 2 are very, very important. Because if you mess these 2 up, when you produce your ISOs, it is going to kick up problems. Now, for instance, I know my one over here, for instance, it should be, if I remember correctly, SO FL, so slip-on flange. ISO symbol key, I can't remember that one straight off, but I'll quickly look that up in a second. I'll come back to that. What I do want to show you guys here is this section now. So this, as you can see, this is a bit of a jumping backwards and forwards thing, but once you understand it, it's a little bit easier to get. So firstly, you want to take a look at your port 1 details. Port 1, what is it going to be mating to? So here, FL for flange, standard, all this stuff, just make sure that it relates back. And a very important one is what face. For instance, this face is going to be a raised face. Just remember, you can't really, it's not really good to have a raised face meeting a flat face, and Plant also gets that, and it will kick it up as an error if you do try and do this. So raised face to raised face, flat face to flat face, but there is ways to modify that, and that is going to come into play with the joins. But yeah, then also your pressure classes, schedules, etc. These can be used kind of like little checks to make sure that whatever component you are trying to attach to is going to be allowed to attach. Because if you get somebody that's trying to do something incorrectly, it should kick up an error. That's where you want it to kick up an error, where somebody accidentally does something. But very importantly, remember what I said just now about having to make sure that your two ports are the same. And in that case, you could do it. And here you can't do it because whatever you're mating to, you're going to have a flange n-type on this side. But opposite side, you can't have a flange n-type because remember, this is going to be slipping onto a pipe. So this actually can't be a flange, but if we use the drop down, it should actually be a slip-on. And that's something that you want to be careful of. The rest of these are not going to be too important over here. So this is the basic detail. This ISO symbol type, give me 1 second. I'm just going to hit save. Just remember to save. Like with every other CAD program, save early and often. And if you actually take a look, it's jumped into my system over here. So if I jump back to, let's say, where do I have another flange? Okay, there's my blind flange. There's my other flange that I've got. Flange. Okay, yeah, it's just called flange. So FLSO, sorry. I'm having my dyslexia pop up again, it seems. FLSO. That is the ISO symbol key. So basically, this ISO symbol key is in the background. When it's generating the ISO, it's going to look in your 3D model, and it's going to use that. And it's going to use this ISO symbol key, tie them together, and that's what the symbol, it knows where to put it in your model. So these two, very important for when you're generating ISOs. And basically, that is a very basic way of individually creating your parts. Just make sure, like I said, if you're in doubt of any of these, do what I've done here. Don't be scared to go and jump to another catalog, like there's the DIN one. And if I'm not too sure what something is or what it's supposed to be, I jump to a, let's say, like this elbow, for instance. Elbow, there's its ISO symbol key, there's its information. So it's very fast and easy to actually just jump around, find a similar item, and then just figure out what data you need to pull across. And what you can also do, by the way, if you are inclined, is you could actually right-click on you see I'm in a different catalog completely, and if you do need to open up another catalog, you can just go open, and it should bring you to your location where it's automatically installed, and you can then find another catalog to open. I've currently got this one open. I'm just going to hit cancel here because it was pre-opened when I opened the system. So for this case, let's say I like this T. What I can do is I can right click on it, go copy, come back to my catalog drop down again, and go back into the one I've created here, and I can right click and paste it in. So you can actually grab bits and pieces from other catalogs and then reuse that data later on. I do caution you to be very careful here because, like I said about this, if you go to the sizes, if your sizes of your matching pipe IDs are not OD, sorry, in this case, is not correct, it is going to kick up errors and it is going to cause you a world of problems. And it can be very difficult to edit lots of information at once. This is when we will start using this export to Excel, but that's a whole nother garden path. I've actually written a blog and a few other things on this, which you can catch on the Micrographics blog site. Okay, that being said, this is how we would basically create our parts. Very, very, very quick intro into it. There's a lot that can go into it, and you can go all the way down the rabbit hole if you want. But now that we've got this parts, where do we go from here? Well, that, in continuation of our rabbit hole, whoops, a little bit further there, is how to then we'd set up these joints and stuff with it, and then also with the spec itself. So using this, what I'm going to do is I'm going to quickly create a spec out of the system. So in this case, if I jump to my spec editor, my spec tab, you'll notice that I don't have any specs in here. I don't have any spec in use. So what I can do is I can go File, New, create a spec. So what am I going to call it? So MGFX 001. I know, very original. Load a catalog. If you do have a catalog that you've got currently that you want to load in and then edit with it, you can do that. In this case, I'm actually working the other way around. I've already started working with my catalog, which I just find is an easier way of working actually in this case, because I've already started with my warehouse of all my parts. And now what I'm going to do is I'm going to take that warehouse, I'm going to weed it out, and I'm going to create my spec from here. Description, so I'm going to call it MGFX. You don't need to fill this out. I'm just filling it out for interest's sake. So MGFX test spec. And I'm going to create. And as you can see, I've got a wonderful blank spec. It just tells me the name of the spec, where its file location is, and some other information like save date, time, etc. At the bottom here, you can actually see my catalog that's already been opened. And if I jump to my catalog tab, you would see it's exactly the same information. I'm just going to jump back to my spec. And I'm just going to select all the information. I'm going to shift and left click, and I'm just selected all this information here. And I'm going to click add to spec. So now you can see all of it is now being added in here. Pretty cool. Now, one of the things I'm going to get into a little bit later on is also this ordering part, but I'll get to that in a sec. So to actually run this off, now what we've actually done is created this base spec, and we could hit save and we could carry on with there. But one thing that I did want to touch on beforehand, before even getting there, was about these little things that we've been talking about, which is the end types. Now, this can be a little bit more difficult to get because you need to know that plant is it's separated into the two areas of between the spec editor and also the back end of that intelligence that sits in the plant program itself. So you kind of have to know to do this in two sections. So for here, for instance, what I've done is with this temperature gauge, all I've done is I created a brand new type called TS, temperature sensor. I don't know, it can be anything. You can call this whatever you want. You can say hello as a type if you wanted to. But for this case, I'm just going to keep it as TS because it's a new one that I've made, temperature sensor. So that is what its end type is. You'll notice though, it's only got one port connection. So you can create this temperature sensor as whatever you want. So once you've done this on the plant side, and that's all you had to do here. Now what you have to do is create this though on the plant side. I'm just going to quickly jump to my plant section. Oops, keep opening up the wrong one for some reason. Ah, there we go. Sometimes helps if you click the right window, hey. So now I've got my lovely plant model over here. Just a little test one that I love to play around with. But over here, what I'm going to do is I'm going to quickly create the encode for it. So plant encodes is what we're after. So you have to type in this command. I know it's a bit of a strange one. Just ignore the spec update bubble at the moment. But we need plant encodes. Once you click plant encodes, this plant encode menu will pop up. Now, this is why the system is a bit convoluted and people don't do this correctly. And I wonder, why is none of these things working? Why do I keep on getting these errors? And this is one of the reasons why we keep getting these errors, actually, is because of this. Because they don't know about this specific step. And this is quite important. So in here, you can actually see I've edited this in. But I'm going to just delete that encode out. And I'm going to go add. And it's going to ask me to add an encode. So this encode name, remember what we called it in the spec side? We said it's TS, that's its encode, and what description it has. Okay, in this case, the description is it's a temp sensor. I'm being just a little bit lazy here. And these are just extra options that it's going to give you. So is it going to be able to create a cutback joint? Is it going to be flange-like, which it actually is? is going to be wafer-like. Just remember, wafer would be something like a butterfly valve. It's sandwiched. The butterfly valve itself is sandwiched between two flanges. Hence, the reason for a wafer connection. And if you actually do ever edit a butterfly, it's both of the ports are going to be wafer connection. And I'll get to a little bit more on the ports in a second. For now, let's add the encode. I'm just going to go OK. And you can actually see I've got my encode TS and my temperature sensor in the description. And you can see all my other encodes. Once you're happy with that those are the ones you want, you can click OK. And believe it or not, there's still more we have to do in the back end. As I said, a little bit convoluted. But in our Home tab, we just click the Data Manager, or Project Manager, sorry. We wait one eternity for the Project Manager to open. Now, inside our project setup again, in our Plant 3D drawings, we have got our piping connection settings. So if you scroll through this, it can be quite daunting to try and figure this stuff out. But if you approach it just slowly and logically, it starts making sense. Firstly, a simple joints is exactly as to what you would think. It would be, how does something like a flange connect to a piece of pipe? What joints are allowed and what joints are not allowed? In this case, you can see the pipe joint BV, so the butt weld, is able to connect to itself, so BV, and also plane, and vice versa. So these two are interchangeable. Same with the butt weld joint, below. That was a pipe end that I was looking at. Mixed butt, same thing, but now socketed. It can only be plane to socket welded, or SW. Now, how do we then add our own one in here? It's quite simple. We can either go add, and we can add in our own completely new joint, which is pretty simple. You just have to go TS, whatever it is. The display name itself is going to be maybe, let's say it's going to be our temp sense again. Now we've got our connection settings, and this is where people get a little bit confused because they've got the same stuff duplicated either side. But what I normally suggest is just, if it's going to be a single side, just select the same as you would on one side as you do on the other. So for instance, I know it's going to be flanged, FL, and I know TS, if I scroll all the way down through my one, is going to connect. And the same thing on the opposite side, flange and TS. Our required properties is over here. So what this is doing is it's looking on either side to see how is the system going to connect up. So I'm going to click add a property, and I'm going to say, okay, well, how does the system connect? Okay, well, what is it looking at? What is it going to compare between the two? So you want to do things like match the pipe ODs. Okay, make sure that the pipe ODs match 100%. Add another property, because we want to do things like, does the faces match? So you'd see facing. Do the faces match? Cool. And vice versa. You can add all these, or what you could do is click on it and take them away if you wanted to, just for in case you maybe want to loosen up the spec a little bit. You also get your fasteners. How are they going to be attached together? In this case, something like a bolt set. Or otherwise, are they going to be welded? Depends on what you want. When you go add, doesn't look like much has happened, but if you scroll all the way to the bottom, you can see your new one has been added. If you do get lost, if this is not making sense, like I said about the spec side, select just one of these, let's say the flange joint, and go modify. And you can actually see all of the stuff, how it's set up and how it's working already defined. And this may aid you in trying to create your own ones. For this case, for instance, I'm going to use my flange joints, and I'm going to go to my TS and just check them both, because this means that they will automatically apply. And then instead of normal accept, we've got modify. We can take it from there. These compound joints that you see at the bottom here are basically, if you're going to be doing things like, if you chuck a flange in the middle of a pipe, what's it going to do? In this case, like for instance, you will auto flange that it will connect a flange to a flange, or however it would then add on. And that's what this connection part is over here. A little bit more complex. I'm not going to get too much into that right now. What I wanted to do is just show you how this stuff is brought across. So with that, I've actually now, I'm going to click OK, and this is all the backing done that we needed to put this part together. I'm going to jump quickly back to my sheets over here. And remember my spec editor. I've got my spec I've now created. Now, this is where the magic is going to actually start happening. Now, before I bring the spec in, and we're going to see how everything works, I just wanted to point out, you've noticed that I've got a few of these little warning signs over here. So this is part priority. Now, this can be very, very useful because a lot of people then complain, why when I'm trying to route my pipe, why do I have this 45 that keeps on going off every single time instead of my 90? Because your part priority is wrong. Now, you don't need to specify these, but it is very useful. Like, for instance, if I were to click this little warning sign, it gives me these size conflicts because it doesn't know, because we haven't marked it. We haven't said what should you use first. So, and what I mean by that is, if I click on this 80, you can see, firstly, it's going to try and use a bend 90 before the bend 45. Now, in actual real world, when we're routing pipe, this is what we want. We want our 90 degree to be used primarily, unless we want to change it to a 45 degree, because not as often we're going to be using the 45s. If this was the other way around and 45s were used, it would mean that if you did bend the pipe 90 degrees around, it's going to use two 45s instead of 190, which if you start reading pipe in it, you'll get annoyed with it really fast. I can promise you that. So in this case, this is actually correct. So what we do is we will go through all of our sizes, and as you can see, all our sizes are correct. If we did have a problem, we could click one of them and use our buttons over here to change the part priority. I'm going to leave it as 90 at the top, select both of them, and say mark as resolved. Okay, cool. Once they're resolved, you'll see the little warning signs go green, meaning it's fine. For the rest of these, just to show you, I'm not even going to bother setting them. They are there. You can set them if you want, as to whatever you want as your part priority. Actually, I think in this case, I'm going to select this one, and I'm going to make sure that my size conflicts, my created one over there, is set first, just to make sure we avoid any issues. So now that our spec is done, how do we load this into a project? This is pretty simple. If you were firstly creating a project, because if you've already, if you're starting from scratch and you didn't have any projects created, that would be the easy part. But now I've already created this project. What do I do now? Because I can't just pull all the information, because when you first create a project, it's going to look in that catalog folder where everything is stored and bring everything through. And if you've ever expanded this list in a project manager, you'll know that this can be a lot of information. It's in fact, it's an overload of information. So one of the first things I do is I go and I de-weed. I'm merciless. I'll go through that whole thing and I'll chop out anything that's not needed. And then what I do is I'll populate it with the correct data, just to make my life easier. Or otherwise, I'll just chop out the stuff that's not needed. Now that I've got this project that was already created and open, and I want to load in the new one, it's very simple to bring this one in. That's what I want. I'm going to right-click on the pipe spec, and I'm going to say, copy specs to project. What this will do is it will look in the original file location. And I know I've saved it in here somewhere, and lo and behold, there's the one I created. Remember, the MGFX 001 and the timestamp at 25 past. Time flies when you're having fun. When I go open, it loads it into this project. Now, here's a critical little fact. When you do this, what it's done is it's loaded it into your project. Now, if you do want to edit the spec again, you have to remember to edit the spec itself, because it's created a clone, a copy of the spec. So it's not referring back to the original one anymore. So if we do want to do any changes, we're going to have to right-click on it and then say edit spec. That would be your easiest way of doing it. You could, if you wanted to, go into the original one and copy it over it and then cycle with that if you really wanted to. But this way is much easier. It's just right-clicking and saying edit spec. That being said, now that I've got the spec down, what I can do is I can use my little drop-down, and you can see there's my spec in the list. When I click on it, take a look on the right side. Oh, my list didn't populate this time around. Yay! It's just trying to make me look bad, that's why. Let me just save, jump off it, and jump back onto it. Oh, and it's not pulling it through. Let me take a look. It may be on this side that I haven't saved. Oh yes, that's the reason why. It's because I didn't save. This is the reason why you always want to save early and often, as I said previously. So what I'm going to do is I'm just going to quickly jump off the spec again, remove it out. Yes, I want to remove this. By the way, a lot of your stuff, when you remove it, it actually gets put into kind of like a trash bin folder in the actual project. So you don't necessarily actually lose it if you delete it. There's ways to recover it. I'm going to go copy specs to the project again. Now you can see the time date. We can see it's now been saved. So now, lo and behold, let's click on it. And yay, we've got all of our stuff that we've created. And as you can see, this is all our new stuff. So there's my new piece of piping. I'm going to select my piece of pipe and I can start routing my pipe. So in here, if I scroll in, this is my 80. And if I were to go around, you can see my bends are correct. If I select my center of my pipe, I can route my pipe out. Oh, wait a second. Here's a problem. Can you see how this T is now broken out? So that will bring us into a section I'm getting onto in a little bit, which is my last section, which is going to be the branch editor. Just quickly showing you this, though, is that what I could do is carry on with my routing. And I can go into 100, and you notice it immediately chucks in my lovely little reducer. Even though it's going up, it's still reducing. My 125, and it reduces again to 125. So as you can see, this is actually a working viable spec. And if I were to chuck my flange on the top, hey, how's that? It even flanges correctly. Now, if I were to delete my top flange, I can use my temperature sensor and chuck it on top. Remember, though, the temperature sensor had that TS connection. And if you go into its settings, you can actually see the port name is S1 and N-type connection is TS. If I tried to do this beforehand, it would have failed because that N connection was not there. And you probably have seen it yourself if you played around with plant a lot. If you're trying to play around with different ports, you put misinformation in that port, it's going to complain hectically. And this is the way that you can get around it. So I've now got my very ridiculous looking temperature sensor on a 80 nominal ball flange. Normally, as probably you'd know, this would be about, what, 25, so 1 inch. But for this case, I just wanted to show you this. Nice. That being said, I now want to quickly address what's going on over here. Because what you could do, this is actually done more of a stubborn connection, but it's really poorly done over here. So this brings me into my last point. So what we've covered over there was basically how the joints, the specs, and now we're getting onto our branch editor. So what is our branch editor? That's exactly what this section controls, is this type of a joint. Now, the branch editor, you've noticed when I've jumped back into my spec editor, I've been in our catalog and I've jumped to my spec and then I created my spec. Once you've got your spec created, you have the ability to then go into your branch editor. Now, in a nutshell, literally your branch editor allows us to take all of our bits and pieces and then say, okay, what is the order priority? How is things going to branch off? Like for an instance, if I click over here and go edit my legend, it's always a good idea to add the legend in first. We go add a branch. We're going to say, okay, what pipe is going to be used? Okay, pipe preferably, let's see, 80 to 120. Legend symbol, nothing there. Because what this is just the normal pipe. I'm going to add another one, and I'm going to use a drop down. I'm going to say, okay, if it tees off, you can actually just leave this blank for this case. It's not going to affect us. This is just what pipe sizes we've got available. In fact, let me just set it properly. So firstly, if we've got a change in size, is it going to T? Yes. Okay, cool. In fact, let me move that one down. So if it T's and it's the same size, it's just going to be a T90. But if I've got another T and it changes its size at all, you don't actually specify the change in size. I'm just going to say it's going to add a reducer. You don't even need to worry about it changing size. But if it does change size, it will use a reducer. So you can see the legend name T actually fills in most of the stuff for you. You don't even need to worry about it. So what I'm going to do is use the pipe, and I'm going to push it all the way to the bottom because I want that to be the last thing. What the rest of these would be is things like if you had a T that was a reducing T, you could have a reducing T and have that somewhere in it, because if you've ever bought a reducing T before, you know that it's probably a lot more expensive than a T and a reducer. But sometimes if you've got space considerations or something like that, or just pure aesthetic, you might want to use a reducing T instead. Or otherwise, with piping, you could even have a stub-in connection where the pipe, if let's say an 80 nominal ball goes directly into 100, it just stubs in. I'm just going to quickly be moving this around because I'm going to be running out of a bit of time. But in this case, just to quickly sum up the rest of this, we've added a branch. You can also select the branch and remove it if you want, and then adjust its priority. You've also got to say what this is basically about. This is just labeling. So it's going to call the header title and the branch title. That is it. Legend notes, exactly as you could imagine, the legend notes itself, just explaining what you're doing, and then what location it's in, and then some of the branch list details. Just to rush us along, I'm going to go okay here. Now that we've got that defined, now we can say, okay, how is this system going to react to what? So when we get to a 80 and 120, we can select it and then double click. And we can say, okay, how is this going to react? Is it going to just do a T, or is it going to do a T and a reducer? In this case, yes, I'm going to do a T and a reducer. Say valid branch sizes. I'm just going to click cancel. You notice that if you do something it doesn't like, it is going to flag it in red. So it's like, hey, wait a second, you've done something funny here. So if I put both of them in, select valid, doesn't have it there. So what it's complaining about at the moment is I don't have a valid connection between those 2 points. Okay, cool. If I go T90, go okay there, you notice that I've then got a reducer. I've got a system that matches, so a T and a reducer that matches between this 100 and this 80. And same over here, I could go T and a reducer and go okay. Oops, do not change. So I've got some area in my 125 because somewhere in there I don't have a system that actually works with these two. So I need to go back and then say, hey, wait a second, what is wrong with my spec? A change. Oh, as you can see, there's a few things that it doesn't like. But once you're done, you can hit save. Okay, now I've got a slight problem though. So I've got all this drawn, but now I've now been editing it in my spec that I already had open. Sorry, excuse the dogs. So what I'm going to do is going to change off my spec. I'm going to delete it out. Oops, it's gone. I'm going to copy it back in. I should have actually just edited it in here. It would have made my life easier. There we go. We can see that there's that's its time. Oops, wrong one. That's that time that's been modified. Now what should happen is that when I branch off here, which is my 80 to 100, well, actually, let me just create a new one. It's going to load up. So when I've got my 100 pipe, and when I branch off here, and it's a 80 nominal bore, haha, and there's our victory. So that then is basically telling it, when I just edit that branch connection in, this is how the branch connection is now decided that it's going to put our T and our reducer in. And that is what we determined over there. To fix these up, I'd literally have to go back into my catalog and determine what is the error, why is it not wanting to combine these systems correctly. It may be a sizing issue, it may be something else. I did actually pull this one off from the DIN, so it may be the DIN one that is giving me a bit of issues. But yeah, apart from that, that is the basics of how you can put your specs together, add some joints, put your table connections together, and everything in a nutshell. So thank you for joining me on that. I know it was quite a quick run through a lot of information, but I was hoping, do we have any questions that we have? Give me 1 second if you can put it into the chat box. No questions. No. Let's see this. Then I just clicked. Audio settings. Yes, there is a chat that you could just write into the chat box if you want to ask any questions there, please. Otherwise, Aldred, is there a way that I can give people speaking permission? Okay, guys. If you're unable to find the chat, it should be on the right-hand side if you expand the menu. And in there's a little chat feature. There we go. How are bolt lengths managed? That's actually a very good question. Now, bolt lengths are actually managed inside the catalog editor under fasteners. So in the fastener itself, you do have sizes. And this is managed in the background, the lengths themselves. Now, you'd have to do some jiggery pokering, but there are ways of actually manipulating in the back end, particularly in the back. That's going to take a little bit to going through. But if you are more interested in it, that's basically some of the length there, but you can get more out of it in the back end. If you are interested, just drop me a mail and I can go into a little bit more with you. By the way, guys, my email, if you're interested in, just drop us a mail, but my one is there we go. So if you look in the chat, I've just quickly chucked my email address in there, and you can drop me a mail from that, and we can have a further discussion on that. But yeah, so you can actually manage it in here as well. Do you have any other questions? Otto, Bing, Aldred? Well, I'll wait a little bit longer, but I do want to thank you guys for joining me. I hope that it's given you some insight into plants. Also, how much that I can talk in a very short amount of time. Cool, guys. Well, thank you again for joining me. It's been an absolute pleasure. I hope to see you guys again with one of our other webinars, especially one of mine, Aldred's, or one of the other guys. Thanks again. Have a good one, guys.